This is Geometry Chapter 5 Test Review, and we are picking up on page 335 in Lesson 5-5, and we are still looking at the sides of a triangle. So this is something that you may have struggled with a little bit in our lesson, and that is doing a problem like example 4. It says, finding side lengths. The lengths of two sides of a triangle are 6 centimeters and 11 centimeters. Find the range of possible lengths for the third side. So we're going to do this one in my notebook. What we need to do, first of all, is remember the triangle inequality theorem, and that is that any two sides of a triangle must be greater than the third side. So let's try that with the two sides that we do know. And let's label this one S for side, okay? So we know that if we add up 6 plus 11, it has to be greater than S. And we'll come back and do the math on that in just a minute. Let me move this so you can see it. Now, we've gone in this direction. I'm going to keep going around the triangle. Now I'm going to say that 11 plus S must be greater than 6. So 11 plus S must be greater than 6. And lastly, I know that S plus 6 must be greater than 11. S plus 6 must be greater than 11. Now remember, we cannot have a negative length. We cannot have the negative side of the triangle. So any negative answers in our inequalities are going to be discarded. But let's start with our math right here. 11 plus 6 is 17. So S must be less than 17. That's going to be the upper end of our range. Let's try this one. We're going to move the 11 to the other side, but it's going to become negative. S is greater than, what is that going to be? Negative 5. So this one we can't use because we cannot have a side length that is negative. And then let's do the last one. Here we're going to solve for S on this side, to our inequality sign, and 11 minus 6 is 5. So our range is from 5 to 17. 5 is less than S, so let's do that. 5 is less than S. Notice that looks backwards from what's up here, but as long as I switched the side of everything, then it still says the same. This says S is greater than 5, or 5 is less than S. This says S is greater than 5, or 5 is less than S. So it says the same thing. And then here we see that S is less than 17. So 5 is less than S, which is less than 17, and that is how you would write that answer. Okay, so you're welcome to watch that over again. You're welcome to look at examples in your videos that go with your homework, but I'm going to keep moving. Let's look at the hinge theorem. All right, well, actually, yeah. Let's look at page 340. Okay, the hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, but the included angles are not congruent, then the longer third side is across from the larger included angle. So if we're comparing two triangles, if two sides of one triangle are congruent to two sides of another triangle, but those included angles are not the same, not congruent, then the lengths of these third sides cannot be congruent. The one that's across from the larger angle is going to be the longer side. So in this case, angle A is greater than angle D, so BC is going to be greater than EF. And the converse of that would just be if two sides of one triangle are congruent to two sides of another triangle, but the third sides are not congruent, and here that's GH and KL, then the longer side, of course, is still across from the larger angle, and the shorter side is across from the shorter angle. All right, so think through that. Remember the thing that we do with our arms where we make the right triangle and then we make it a hinge. If the angle gets smaller, the side across from it gets smaller. If the angle gets bigger, the side across from it gets bigger. And you will be asked on the test to compare triangles that way. So you need to be very familiar with applying the math of this. Let's look at example B just for a quick mathematical application. Page 341, example 1B. So here, this question says, compare KL and MN. Here's KL, here's MN. Really, well, okay, here's our helpful information. It's that this side, Kn, is congruent to Lm. They're both 6. And the Ln is congruent to Ln by the reflexive property. So we know that we meet the criteria for using the hinge theorem because two sides of one triangle are congruent to two sides of another triangle. But we also know that because these included angles are not congruent, that those third sides also cannot be congruent. So the test might say which of those sides is longer, or compare the two sides. And you would say, if that were the question, you would say LK is less than MN, or MN is greater than LK, because MN is longer, being across from the larger angle. LK is smaller or shorter, being across from the smaller angle. Okay, I'm trying to move fast, so I'm like speaking gibberish. All right, let's look at one more, and that would be C. Find the range of values for Z. Sorry, you can't see that, can you? Find the range of values for Z. So here we're comparing two triangles, and let's look at what we know. We know that UV is congruent to VW. So we have one side of each triangle congruent. We know that VT is congruent to VT, reflexive. So we have two sides congruent in one triangle to two sides in another triangle. But we see that the third sides are not congruent. TU is not congruent to TW. So therefore, we know that the upper angle here is going to be less than the lower angle. Let's look at that on paper. 6Z minus 3 cannot be equal because its opposite side was smaller than or shorter than the angle opposite the 45-degree angle. So I say 6Z minus 3 is less than 45. Now, they want a range again. So we're going to solve our inequality here. We're going to say 6Z is less than 48. Z is less than 8. So there's one end of our range. Now, how do we find the other end of the range? And I know this is probably going to be hard for you to remember. We set this equal to 0 for the smaller end of the range, knowing that no angle measure can be 0 or there would be no angle. So let's do that. 6Z minus 3 has to be greater than 0. 6Z is greater than 3. Z is going to be greater than 0.5 or 1/2. So I would write this as 1/2 is our smallest possibility, is less than Z, which is less than 8 based on our first answer. All right, moving ahead, and let me check the time on the video. It's good. Okay, inequalities, hinge theorem. Okay, let's talk about Pythagorean triples. We'll come back to the overall Pythagorean theorem in a minute, but let's talk about Pythagorean triples for a minute, because that is next on my list. This is page 349, and all you need to remember about the Pythagorean triples is that they have to be three numbers that work together to make the Pythagorean theorem work, and they must all be whole numbers. So if you get a side that is a radical or a decimal or a fraction, then that combination of numbers, even if the other two are whole numbers, that combination of numbers cannot create a Pythagorean triple. In a Pythagorean triple, all three must be whole numbers. Now, if you were given three numbers, you might say, oh gosh, how do I set this up? In the Pythagorean theorem, I don't know which two are the legs and which one is the hypotenuse. But actually you do, because you know that your hypotenuse is always going to be your longest side. So if you needed to see if these three numbers would work to create a Pythagorean triple, you would have to have the 17 as the c squared and the 8 and the 15 as the a squared and b squared. Here, you would have to use the 13 as your c squared. All right, so biggest number or longest side is your hypotenuse. Okay, let's look at the Pythagorean theorem. I know you know this. It's a squared plus b squared equals c squared. Super important. If you don't have that cemented, it absolutely must be. Okay, let me think about this for just a second with what we need to talk about. Let's look at this triangle right here. So we're given a triangle with a side of 4, a side of 6, and a side of x. We are going to plug these in. 4 squared plus 6 squared equals x squared, because x is my hypotenuse and c is my hypotenuse. So 4 times 4 is 16, 6 times 6 is 36. This is going to equal x squared. Let's add up the left side, and that's going to be 30, 40, 52. Now, so 52 is not our answer because x is still squared. We need to unsquare it by doing the square root, and that's going to make x squared become an x, and 52 is going to become 4 radical 13. But let's look at how we got there. I might not have known that 4 went into 52 evenly, so I need to look for perfect squares like 4, but I can just break this down as far as possible, and that will help me. So I can tell it's even, so I'm just going to say 2 times 26. Well, obviously I'm not done. Let's keep going because 26 is still even. So 2 times 2 times 13. That 2 times 2 is a perfect square because 2 times 2 is 4. Anytime, like right here where we had x squared, the square root of x squared is x. The square root of anything times itself is going to come out to be just that number or just that variable. So 2 times 2 means that 2 must come out of the radical, and you're left with 13. And that is your final answer there when it's reduced, okay? All right, I don't think I have time to keep going through these, but I will do one more that uses a binomial. Let me check the time. We're good. Okay, so this one, I'll just show you the picture in the book. The right triangle has a side of 5, a side of x minus 7, and a side of x. I'm not going to do it on my paper. We're just going to walk through it here. So we say 5 squared plus x minus 1 squared, in parentheses, don't forget that's super important, equals x squared, because that's our hypotenuse. So 5 times 5 is 25, and we must FOIL, and some of you had a hard time remembering that acronym and what you do with a binomial that's squared. We must FOIL that binomial. So that would look like x minus 1 times x minus 1. So FOIL, first, outer, inner, last. The first are the x times x, or x squared. There it is right there. The outer is negative 1x, or x times negative 1 is negative 1x. The inner is also negative 1x. Negative 1x plus negative 1x is this negative 2x right here. And negative 1 times negative 1 is positive 1. So there we have FOILed it, and we have our solution to that in the middle of our equation. Now we have to simplify by combining like terms, and we also notice that when we subtract x squared from both sides, it disappears. So then we're able to go on to solve. Now this FOILing is from Algebra 1, so, and maybe even some in pre-algebra. So if you're struggling with that, do some Google research and get help with that. Okay, let's see. The next thing we need to look at, y'all